Dear students of class 12 science, I am Nabi Hassan, your chemistry teacher. Today, through this video, I am going to start a new chapter. The name of the chapter is the solid state. Now, in this chapter, we study about the solid, different types of solid, again, different types of crystal lattice, different types of unit cell. So let's start. So first, what is solid? Now we know matters, they are classified into three types based on the physical state. That is solid, liquid and gas. Now the difference between these three is the distance between the particles. Now because of the distance between the particles, the properties also differs. In case of solid, the particles are closely packed. So we can say it's a compact packing. Now, since the particles in solid are closely packed, they have minimum intermolecular distance. And since they have minimum intermolecular distance, they have maximum intermolecular force of attraction. And because of this compact packing, solid, they have definite volume, they have definite shape, unlike liquid and gas. So this you can write it as the characteristics of solid. So if you have to define solid, what is solid? It's a state of matter in which the particles are closely packed. They have definite volume, definite shape. The particles, they have minimum intermolecular distance and they have maximum intermolecular force of attraction. Next, the classification. Solids, they are classified into two types. They are crystalline solid and amorphous solid. Amorphous solid is also known as pseudo-solid and is also known as supercooled liquid. Now the difference between these two types of solid is the arrangement of particles. In crystalline solids, the particles are arranged in a certain order. They follow a certain pattern. Whereas in amorphous solid, they don't follow any pattern. It's not orderly arranged. So what we can write, the first point of difference, we have regular arrangement in case of crystalline solid. But in case of amorphous solid, you can write irregular arrangement. That is, in case of crystalline solid, the order is a long range order. That means the particles, they follow a pattern for a longer range. But in case of amorphous, there is no orderly arrangement. This irregular arrangement, even if they have this orderly arrangement, like here you can see 1, 2, 3, it will be short range. Only for a short period of time or distance, they will follow this pattern. Next difference between crystalline and amorphous is based on melting point. Crystalline, they have surf melting point. But amorphous, they don't have surf melting point. Now, what is surf melting point? A solid, if it melts with with a sudden rise in temperature, then is said to have soft melting point. So crystalline will increase, or if you increase the temperature by a certain range, it will melt. But amorphous, they don't have soft melting point. They melt in a certain range of temperature. They don't melt at a particular temperature. They follow a range of temperature to melt. Now the third point is based on direction, that is also known as directional property. Crystalline, they are anisotropic, whereas amorphous, they are isotropic. Now what is meant by anisotropic? Now we know a solid, the particles are arranged along three different axes, that is x, y, and z. Now, say this is a solid, this is x-axis, particle along x-axis, y-axis, and this is z-axis. Now here, if the properties of the solid, like there are different types of properties, now if the properties of the solid remains same along all the axes, then it's known as isotropic. But if it differs, if the properties are not same along all the axes, it's known as anisotropic. That means, in case of crystalline solid, the properties of the solid will differ along different axes. Whereas in the case of amorphous solid, it will remain same. The fourth point is based on heat of fusion. In case of crystalline solid, they have definite heat of fusion. Whereas amorphous, they don't have definite heat of fusion. So from here you might be asked to write down a difference between crystalline solid and amorphous solid. If they give you 2 marks, write 4 points of difference. If they give you 1 mark, write 2 points. Next, we'll study the classification of crystalline solids, meaning different types of crystalline solids. Now, crystalline solid, they are further classified into 4 types. They are molecular solid, ionic solid, metallic solid, and covalent, or is also known as network. Covalent or network solid. Now this classification is based on the intermolecular force. Intermolecular force to constitute the solid. Like molecular solid, they are made up of molecules. So based on the interaction between the molecules. Ionic solid are made up of ions, so based on the interaction between the ions. Metallic solid, metals surrounded by sea of electrons. Covalent solid, the atoms are linked by covalent bond. So these are classified. This classification is based on molecular force. Now molecular solid is further classified into 3 types. That is polar, non-polar, and hydrogen bonded solid. Now polar are those molecules where the dipole moment is not 0. Non-polar are those molecules where the dipole moment is equal to 0. And hydrogen bonded solid are those solids where we have the hydrogen bond. The hydrogen bond will be between an electronegative atom and hydrogen atom. So let us study each of these solids in detail. So first, molecular solid. So molecular solid, the first type is non-polar. So this non-polar molecular solid, they are made up of molecules. And the molecules, they are held together by a force, and the force is dispersion. Dispersion, or is also known as London force. This is a weak force of interaction. They are a poor conductor, that means they act as insulator. And they have very low melting point. Examples, you can give H2, I2, CCl4, etc. Next is polar solid, polar molecular solid. Now in case of polar molecular solid, the constituting particles are again molecules. But in case of polar solid, the molecules, they are held by dipole-dipole interaction. Now dipole-dipole interaction is stronger than dispersion force. Now the force is dipole-dipole interaction. Polar molecules are also made up of molecules, so it also acts as insulator, that means a poor conductor of heat and electricity, and they have low melting point. Example, for polar, HCl, CHCl3, etc. The third type of molecular solid is hydrogen bonded. The type of force between the molecules is hydrogen bond, or you can say hydrogen bonding. They are also poor conductor, that means they act as insulator, and they have low melting point. Example, H2O, that is ice, H2O water in solid form, ice. The second type of crystalline solid is ionic solid. So from the name you can see ionic means it's made up of ions. And what are the ions? Cation and anion. If it is positively charged, it's cation. If it is negatively charged, it's anion. Now, ionic solids, since they have opposite charged ions, they will have a strong interaction. So the force of intermolecular force of attraction present in ionic solid is electrostatic. Electrostatic force of attraction. Now, ionic solids, if it is in the solid state, if they are in solid state, they act as insulator. But if it is in aqueous medium, like if you prepare a solution of ionic solid in water, that means aqueous solution, they act as conductor. So ionic solid, if they are in solid state, they act as insulator, but if it is in the aqueous solution, they act as conductor. They have high melting point. Example, sodium chloride. The third type of crystalline solid is metallic solid. Now the metallic solid are made up of kernel. Kernel means positively charged species, and is surrounded by sea of electron. Say Fe2 positive, Fe2 positive, Fe2 positive, these are kernels, and they are surrounded by sea of electrons. These are electrons. The force of attraction or the bonding here is metallic bonding. They are good conductor, so they act as conductor, and they have high melting point. Example, you can take copper, iron, zinc, magnesium, etc. The fourth type of crystalline solid is covalent or network solid. Now, this covalent and network solid, they are made up of atoms. And these atoms are held by covalent bond. So the bonding present in covalent or network solid is covalent bond. They are poor conductor, that means they act as insulator. But there is an exception. If you take graphite, these allotropes of carbon, that is graphite, graphite is good conductor. Except for graphite, the rest of the covalent or network solid, they act as insulator. They have very high melting point. You can take the example of covalent or network solid as silicon dioxide, SiO2, silicon carbide, etc. So this is the classification of crystalline solid. So in the next video, we will study unit cell, crystal lattice, different types of crystal lattice, then we'll study different types of unit cell, then we have packing efficiency, number of atoms per unit cell. So we'll try to cover these topics in the next video. Thank you.